If the transconductance of M1 is 5S, voltage gain for the following degenerated CA stage is A 2.45, B 1.25, C 1.45, D 2.25. The correct answer is 1.25. If channel length modulation is present and Gm is the transconductance of M1, what happens to the output resistance of for a fixed V2 in the following circuit? A 1 gram rho rupees rho, B 1 gram rho Rs, C rho 2 Rs, D 1 gram rho rupees. The correct answer is 1 gram rho rupees rho. If the output impedance of the current source is Re, what is the output impedance of the CA stage shown below if channel length modulation is neglected? A 1 gram R1 R2 Re R1 R2, B R1 R2 Rho Re, C R1 R2, D 0. The correct answer is 1 gram R1 R2 Re R1 R2. In the following CS stage shown below, what is the transconductance? A 12 ncox WLV1 VTH, B 3 ncox WLV1 VTH, C ncox WLV1 VTH, D 2 ncox WLV1 VTH. The correct answer is 12 ncox WLV1 VTH. If the output voltage is sensed at the collector, which of the following option perfectly describes the stage shown below? A degenerated CS stage, B a CS stage, C a shunted CS stage, D an open CS stage. The correct answer is a degenerated CS stage. Heat dissipation from heat sink take place primarily by A conduction, B convection, C radiation, D all of the mentioned. The correct answer is all of the mentioned. What is a heat spreader? A, an older version of a heat sink. B, another name for heat sink. C, device to transfer heat from device to the sink. D, a connector for coolant to flow. The correct answer is device to transfer heat from device to the sink. Neglecting channel length modulation, what is the voltage gain from the gate to the drain of M1? A Gm R1, B Gm 2 R1, C Gm R1 rho, D 3 grams R1. The correct answer is Gm R1. In the following CS stage shown below, what is the voltage gain from the gate to the drain of M1 if 0? A Gm rho, B Gm 2 R1, C Gm R1 rho, D Gm R1. The correct answer is Gm R1 rho. Heat sinks are provided with peripheral fins to A, provide good appearance, B, increase heat absorption, C, increase surface area of heat dissipation, D, provide material stability. The correct answer is increase surface area of heat dissipation. In the following CS stage shown below, what is the input impedance ideally if channel length modulation is neglected? A, infinite, B, very high, C, very low, D, cannot be determined. The correct answer is infinite. In the following CS stage shown below, what is the input impedance if 0? A, infinite, B, 0, C, very low, D, rho. The correct answer is infinite. The performance of heat sink does not depend upon A, choice of material, B, protrusion design, C, surface treatment, D, none of the mentioned. The correct answer is none of the mentioned. In the following CS stage shown below, what is the output impedance if channel length modulation is neglected? A, 2 rho, B, 5, C, R1, D, 0. The correct answer is R1. In the following CS stage shown below, what is the output impedance if 0? A, rho, B, 0, C, R1, D, R1 rho. The correct answer is R1 row. If both the MOSFETs are identical and have channel length modulation, what is the output impedance at node S? A R1 row 1 row 2. B R1 row 1 row 2. C R1 row 1 row 2. D R1 row 1 row 2. The correct answer is R1 row 1 row 2. What is the overall input resistance of the CS stage shown below? A R3. B R3 R1. C 2 R3. D infinite. The correct answer is R3. Which of the following heat sink is used for low power application? A stamped heat sink. B machining heat sink. C aluminum heat sink. D molded fin heat sink. The correct answer is stamped heat sink. If the internal resistance of the current source is finite, what will happen to the voltage gain? For the following CS stage, if K is doubled, A, the voltage gain reduces by 1 2. B, the voltage gain remains the same. C, the voltage gain increases. D, the voltage gain decreases. The correct answer is the voltage gain remains the same. If both the MOSFETs are identical, what is the voltage gain from V1 to node S? A, VCC2 R1 NCOX WL V1 VTH2. B, VCC R1 12 NCOX WL V1 VTH2. C, VCC R1 NCOX WL V1 VTH2. D, VCC 4 R1 12 NCOX WL V1 VTH2. The correct answer is VCC R1 NCOX WL V1 VTH2.